Welcome to this next video. In this video, we're moving forward from the confirmative factor analysis to final analysis. So confirmative factor analysis is just to show that the items you're using, they're good. Especially if you develop new items, you need to run first exploratory factor analysis and then collect a new data set and run confirmatory factor analysis. Now we're going to make a very simple model, the one that we had before, with the impact of emotions on these four scales. You go now to your data, and in the data we already have the dummy coded for Amos. You need dummy coded variable because it will not understand the manipulation recorded, because it was 0 control group, 1 anger, 2 fear, I think something like this. It will understand that 3 is 3 times 1 or 2 is 2 times 1, like fear is 2 times anger, which is wrong. So this is the categorical variable. That's why we need to code it as a dummy variable. Anger, if it is anger, it should be 1. If it is not anger, it's 0. Fear, if it is fear, 1. If not fear, 0. So and we have control group, so actually we need only anger and fear. We add these variables here, anger and fear. And now we can draw the lines, actually what we want to test. Anger with relation to all these latent constructs. Fear with relation to all these latent constructs. We take the magic wand to make it looking nice, and now we have a problem. It will not run the model because these items, they are dependent variable. If they are dependent variable, they need to have an error term, so we need to introduce the error terms. We add the error term here, here, here and here. Go to plugins and make name unobserved variables, and as you see, it added some names, and now theoretically we can run the model. We're now going to run the model. In the data we also want to have, we have squared multiple correlations which will show the R squared. And for now it's all that we need. If you have missing data, you may need to click here estimate means and intercepts, but if you do it, you will miss some tests. That's why don't do it if you have full data. Do it only if you have some missing variables. And we run the model. It has a message here that, are you sure that anger and fear, they are not correlated? No, they are not. Proceed with analysis. Because they were either anger group or fear group, they didn't have like two things at once. That's why we know they were not collected simultaneously with different groups. That's why they are not correlated. And now we can go to results and see what we have. Model fit remained actually good. Actually very good, but again the reason is that we have the generated data. REMC is acceptable, should be a bit lower than 0.5, but it's still good, and all other indicators are actually good. GFI is not so good, but it's fine. For the confirmative factor analysis is more important than for the test. Estimates, scalars, and here you can find the effects. Anger has a statistically significant impact on behavioral inhibition. The higher the anger, if it is 1, it is anger, the lower the behavioral inhibition. But anger has no impact, no statistically significant impact on behavioral activation. And fear has impact on behavioral activation. If you have the fear, then you are less activated, at least statistically significant in the scale FF, and weakly significant in the scale D. Here are the standardized regression weights, which are very close to the initial ones, just because the variables, they are automatically standardized. That's why theoretical standardization of standardization. In this event, if we talk about the standard deviation, here we would say the higher the anger, the more of units you will get on BIS scale. So if there is anger, the BIS will be on average minus 0.327. Here you would say if it is anger as compared to other emotions, then the standard, it will be, this variable will be at least 0.29 standard deviations lower than in the event of other emotions. And we compare it against the control groups and in having no emotions manipulated. So in this event, we talk about the difference in standard deviations. Here's the difference in the variable immediately how it has been measured. Interestingly, it is also standardized. That's why it's interesting, very interesting to interpret this data. And actually, that was it. But we can do something else, we can do even more. So these results will be very close to those that we calculated with SPSS, will be a bit different because of the one reason we have here a different procedure of how we aggregate. We use the maximum likelihood procedure. That's why the result will be very close, but a bit different. So what else we can do? I'm going to show you, actually, it will not work, but I want to show you what you can do with regression here. We can actually say that behavioral activation is the third level construct. So we have the, okay, this is the first level construct, it will be the second level construct. We have the behavioral activation. Let's assume we have it. Behavioral activation, where was it? Here, and we call it behavioral activation scale O. I know already it will not work, but I'll explain in a second why. So, and we say that this is the construct that has been formed by these three dimensions. And actually what we want to say is that the certain emotions have the overall impact on behavioral activation, doesn't matter what type of behavioral activation it is. So we create a second order construct, and to create it completely correct, remember, if you have the lines going to subordinated dimensions, we need to restrict one of them, regression weight, introduce it as a 1. You can take any of these arrows, but I said it. Now we draw the lines from anger to behavioral activation, inhibition, from here to behavioral inhibition and activation. And magic wand will make it a bit nicer, and what we miss is the error term, because it is now the dependent variable. And again, we need to name this dependent variable, the error term of the dependent variable. We run the model again. It will become worse for a certain reason, I'll explain in a second. And we made the calculation, and now we can look at the results whether the items can be aggregated. So anger has now no impact on BIS all, and fear has no impact on BIS all. But it still has impact on BIS. It didn't change with the behavioral inhibition, it changed behavior activation. So it seems that if we take the overall construct activation and say there are three dimensions and they're perfectly related, they're correlated, it seems to be wrong. How can we know it is wrong? We can simply go to standardized regression weights and look on the weights of these dimensions for the second order construct and look at the weights. BIS, so as you see here, they have perfect weights, everything is as we had before in the confirmatory factor analysis, but now we say actually can happen there is something superordinate, the second order construct. And you see the weights are actually, this one is negative and very low, this one is way too low, so they should be actually the same logic, 0.6 or higher, and they're not related. It seems that they do not build the same construct. It seems they are independent dimension. That is why it makes no sense to introduce the second dimension. I had research and I had papers where we had the opposite, where we have shown that some dimensions, they are so related that we can form a superordinate dimension construct that actually unites the other thing, because they seem to be dimensions, different aspects of the same construct, of the same higher order construct. I had it also too. The paper is now under review, so actually positive comments, so we're now revising the paper, but it was the opposite what we have found. What it learns teaches us that actually we don't need to introduce the second order construct, but you have learned that sometimes you can have the very complex models, and SEM, structure equation modeling using AMOS or Smart PLS, allows you to make this third order construct. I had a study with a third order construct, which we published in 2015, I think, in the EGIM, International Journal of Innovation Management, and it was third order construct. It was even more complex. We had formative related items, but we cannot calculate it using AMOS here. So anyway, I hope it was helpful. I think it was interesting to see what happens with a model if you change something. In the next video, we're going to build a kind of structural equation model with a complex relationship, which is not existent, but we'll try to play with the data. See you in the next video.